So let's read through the words here. 130 adults with gum disease were asked the number of times per week they used to floss before they got the diagnosis. I bet their flossing went up after they were told they had gum disease. So, all right, so the 130 adults, how many times were they flossing per week before their diagnosis, before they were told they had a problem? All right, so let's make sure this data table is making good sense for you. So 0 times per week, 18. 18 frequency is how many people? Let me write that for you. How many people? So that means 18 people were flossing no times per week. That making sense so far? 18 people were not flossing at all before they were told they had the problem. Now that's 18 out of 130, isn't it? It's 18 out of 130. That's how they got this number right here. Relative, whenever they say relative, that means it's the number divided by the total number. So they took 18 and they divided by 130. That's how they got the 0.1385. Same thing here. They took the 20 and they divided by the 130. They took the 22 and they divided by the 130, etc. Is that making good sense? That's how you get relative. Whenever they say relative, it means with relation to. Right? So you're comparing to the 130 out of the total. So they're dividing by 130. So they're finding the percentage, in other words. But it's not quite the percentage, it's the decimal version, but it's the same thing. So it'd be like if I said, so basically we're saying what this is telling us the percentage of people that didn't floss at all. 13%. You know, if we change that to a decimal, we move the decimal 2 places, it would be 13.85%. If I moved it twice. So that's 13.85%. That's what that decimal means. You know how to change a decimal to a percentage, right? Just move the decimal 2 places. That's why there's 2 zeros in the percent symbol. So that's 13.85%. That means 13% of the people flossed not at all before they were told they had gum disease. So relative frequency, you just divide by the 130. You divide by the total number. Okay, we get rid of this. Go back where we were. So, and then what's cumulative? Let me make sure that's making sense for you. Cumulative frequency. To accumulate means to add them up. So this just means add up the frequencies, right? Because it's cumulative frequencies. So in other words, what they're doing is they're saying 18 plus some number equals 34. Does that make sense? And then they added 20. You see 34 plus 20 equals 54. Everybody see what's happening there? So cumulative, this just means they're adding them up. They're adding up these frequencies. So let me try to make that more clear again. So in other words, what they're doing is they're just saying, if we add these up, 18 plus what number will total 34? So let's figure that out. 18 plus what number will total 34? How do we figure that out? What's this number?
18 subtracted by 34?
Yeah, subtract, right? 34 minus 18, what is that, 16? So that number's got to be 16. So everybody see how I came up with that being 16? Because these two frequencies have to add up to be the cumulative frequency on that line. That's what cumulative means. So for example, what if we did What if we did all three? Let's just double check, make sure this is right. If I add up all three of those, they should total 54. You can double check, they do, etc. So we're just adding up the frequency column to get the cumulative frequency. It just means that as they accumulate, as they add up. All right, I'm going to move on. You stop me if you.
Can you go over the relative frequency once again, please?
Okay, yeah. So the relative frequency is by dividing. So whenever they say relative, it's dividing. As it says right here, relative is the number over the total. So that would be 18 divided by 130, because the total's up here, 130 adults. This is 20 divided by 130, etc. All those are the number of people that floss 3 times a week divided by 130. So you're finding out the percentage of all the people that floss 3 times a week or 2 times a week or 1 time a week or whatever. All right. So this was, what was it, 16. So now, excuse me, how are we going to get this relative frequency number right here?
You divide it by the sample.
Yeah, I just need to take it and divide by the 130, right? Take the 16 that I found, take your calculator, take 16 divided by 130. I'll put it up here. 16 divided by 130. I'm getting 0.1230769. Now, let me help you guys with rounding. Let me help you with rounding. I know rounding can often be a sticky spot for people. How far do they want us to round? Let's see what it says down here. Can you see this? 4 decimal places, right? 4 decimal places. And you can just see all the numbers here are all 4 decimal places. Well, that one's just 1, but he must have stopped. All the rest are 4. Okay, so how do I round this number right here to 4 decimal places? You guys good with rounding? What do? You put a line after the 4th place because that's where you're going to stop, right? And then that last spot, that 0, it's either going to stay 0 or it's going to go up. How do you know which one?
It'll be a 1.
Yeah, how'd you know?
Well, because it's rounded above a 5.
Anything
Yeah,
over
because that 7 is 5 or more, huh?
Yeah.
Exactly. Good job. We all good with that? That's exactly right. If this is 5 or more, then you round up. Oops. Round it up. Otherwise, you just leave it as it is.
I have a quick question, Mr. Aaron.
Question.
Say we get the number is 0.15. Do we need to add the extra zeros to that?
Yeah, no, you don't have to. Yeah, if the number just naturally stops on its own, it's a good question. Just leave it. You don't need to put in extra zeros. Just leave it as
Mr. Heron, can you go over how to get your frequency again?
0. Yeah. So we're going to write in this answer 0.1231. There we go. Yeah. So so I'll back up and answer again how we got the frequency. How did we get this frequency number right here? Because these 2 frequencies have to add up to be the cumulative frequency. That's how I got that. So cumulative means add up the frequencies. So when they're telling me 34 is these 2 added up, and I knew this one was 18, then I could find it by subtraction. That's why I subtracted 34, the total, take away 18, that told me this was 16. That's how I knew. Cumulative tells you what they add up to be. So if one of them is missing, you can find it by subtraction.
And then to
I'm sorry, I couldn't hear that.
find like the very last cumulative frequency box, you would add all the frequencies up to get the last number.
If you're missing this box down here,
Yeah.
yeah, you're going to add all these frequencies up for that. Yeah, so any of these boxes, you add up down to that point. So if you're missing the bottom one, you would add all these up to give you the, and by the way, it's always going to be the total. The very bottom one has got to be the total because it's all of them added up. So it has to be all of them. All right, now, and what's this right here? Notice I'm missing the top box. Well, remember, it's just the adding up, and you've only got one number. When you're at the top level, you've only got one number right now. So that's just going to be straight out 18. Because there's only one number so far. All right, and now, final box. Down here, we have this one. What is the cumulative relative frequency of flossing 4 times per week? All right, now this one confuses a lot of people. Let me help you with this one. So how is it we are going to do this one? Well, what we're going to have to do this one is notice it has the word relative in it. See what I said right here about relative? Everybody hear me on this? That's the number over the total. Relative means divide. Are you hearing that? Relative means divide. So when they say cumulative relative frequency of 4 times, we go to the 4 times. I come over here and I grab the cumulative number. That's the cumulative for 4 times, but I need to divide that by 130. Not making sense? So it's gonna, so I'm gonna get a different color here. So yeah, so I'm gonna take the 4, go over here, cumulative, go down, grab that 89, and then take 89 and divide by 130. Why am I dividing? It says relative. That means divide by the total. Relative means with relation to. So it means with relation to the total. So I take my calculator, take 89 divided by 130. I'm getting 0.6846. 0.6846. And now that's a decimal. Notice they want a percentage. You see that? How do I change this decimal answer to a percentage?
Just move the decimal over 2 times.
2 places. So this is going to be 68.46%. The percent's already there. You don't have to write it in. There we go. We are done with this question.
On mine, for the cumulative frequency, I put 70 because that's just.
Okay, so here on number 2, we're looking at what they're saying. So 50 part-time students were asked how many courses they were taking. 26 students are taking 1 course, and that relative frequency is 0.52. Again, remember the frequency column is how many. The relative frequency is the frequency divided by the total, and the cumulative means add them up. That's what cumulative means. Okay, so what is this answer going to be right here? How about on my blank? What's that upper right got to be?
27?
6.
Got to be 56, right? Because this number has to be the same because you're only adding 1 at that point. It's making sense? How about this? What does this next one got to be? How am I going to get the next one?
26 plus 13.
Exactly. Is everybody seeing that? Remember, you add these up, and that's what goes right there. 26 plus 13 is what? 39. That's 26 plus 13. Everybody seeing that? Cumulative means add up the frequencies. Add up the frequency. So I'm adding up 26 and 39 there. I'm sorry, 26 and 13 to get 39. And that's how I knew this was 26 because that's only adding up 1 number, right? So you add down and then go across. You add down and jump across to get the cumulative frequency. All right. And now, let me put these back right in here. We got that by 26 plus 13. Okay, and now how am I going to get this box right here?
You divide 13 by 50.
Exactly. So for my example, we will divide 13 by 50 because there's 50 total. Remember, relative is frequency divided by total. 13 divided by 50, hit the buttons on my calculator. I'm getting 0.26. You can put the 0 in the front or not, doesn't matter. All right, final. Now this might be the most tricky part. How am I going to get that right there?
I thought you would just add the 26 and the 13, but that's for the cumulative. So don't you you have to put 50 in the bottom right, and then don't you subtract 50 by whatever to get
Yeah, that's a good idea. Yeah, this has got to be 50.
that?
Good job. Yeah, and we know there's 50 people total in this problem, right? And 26 of them are taking one course, 13 of them are taking 2 courses. So the rest of the people must be taking 3 courses, right? So you see how I can just take 50 and subtract 13 and subtract 26? Got to be 11.
Would it be better to add 26 and 13 and then subtract 50?
So yeah, right. That'd be the same thing. Right. Is that making sense? So there's 50 total people in this question, right? 50 students, part-time students were asked how many classes they're taking. 26 of them said they're taking 1 course. 13 of them said they're taking 2 courses. So the rest of the people must be taking 3 courses, and that's 11. How do I know that's the rest? I subtracted from 50. That's the total people that were interviewed. So there we go. And then the relative frequency, you know how to get that, right? We divide by 50. So 11 divided by 50 in the calculator is 0.22. And then finally, what percent of the students take exactly 3 courses? So where am I getting that? What percent of the students take exactly 3 courses? Any ideas? Exactly 3?
Wouldn't that be the frequency divided by the 50?
Yeah, right. That's going to be the 11 over 50, right? Yeah, because 11 people take exactly 3 courses, which is 0.22. That's what I did right there, huh? That makes sense? What percent? And then I've got to change it to a percentage. And then you move the decimal 2 places, bump, bump, so 22%. That's the answer. I had to move the decimal to the back.
So say you have 19 over 50 and you come up with 0.02. Would it be 2%?
I don't think that's what it becomes. I'm getting 0.38.
Maybe I'm just doing this wrong.
We'll try that in your calculator. 19 divided by 50?
Oh, yep. I was pressing the wrong button. Sorry.
No problem. Is that making sense? Questions I can answer on that. So whenever they ask you percentage, you've got to divide by the total, don't you? That makes sense? That's how you find what percentage of something. It's the part over the total. That's what percentage is. Like if I said, what percentage of our class is going to end up getting an A? I don't know, maybe 12 people out of 40. And I would divide that on my calculator and I would get a percentage. You always divide by the total, don't you? Whenever we're talking about percentage or something, we're talking about what part of the whole, what part divided by the total. That's what percentage means. Other questions on what I did on question 2? In this one, they're saying a student survey, 52 part-time students were asked how many courses. It's really a lot like the last one. 52 students, how many classes are they taking? All right, so you might have one similar, maybe a little different. So what do you think, what is this box right here going to be? On mine.
22.
Yeah, it's got to be the same as this, right? Because cumulative, remember what that means again? Add the frequencies, right? Well, if the first one is 22, that means the first one must be 22 because you're only adding up one number at that point when you're at the top row, right? It's getting easier. And then how about this number right here? How am I going to get that number on my chart?
What if you have both top boxes empty?
Both of these two?
Yeah.
Did they give you this number?
Yes, they did.
See how these have to be the same?
Okay.
So that's how you would get this one. And now, let's together figure out how we're going to get this second one in the cumulative column. How am I going to get that one?
Take the second column and minus it from first one?
So we add up these two, right? And it goes right there.
Okay, so you add those two together?
That's what cumulative means, remember? Add them up, add up the frequencies. So yeah, you just plus 15 and we get 37.
Okay, so then to be able to get the first columns, you would have to minus the 30. What I have is 33 from the 12. That's in the second columns. Please stop.
So you're saying, so what do you have here?
Both my first and second are the. I'll ask you whenever on the other thing.
These are tricky times. Sorry. All right. 22 was this 37. Okay. And then how do I get this number right here? Remember how we get relative frequency?
Divided 22 over 52.
Yeah, frequency divided by total, right? So this is going to be 22. Yeah, you just divide this by 52. 22 divided by 52. I'm getting what am I getting? 0.42307. Remember, we put the line, they want 4 decimal places. Put the line right here. So 0.4231. There we go. And the last question on mine is right here. What percentage of students take exactly 2 courses? That's this number right here. That's what that is. We've already got it. That's what relative, except we just have to move the decimal 2 places. So take 0.2885, move the decimal 2 places, 28.85%. 28.85%. That makes sense? That's what relative frequency is. It's what part, what percentage. So here you go. So I'm jumping down to number 7, and then I'm going to jump back to number 4 after I do number 7. I think it'll be easier this way for you. So on number 7 here, we have data for the first and second quiz scores for 8 students in a class. All right, and what we're wanting to do is they want you to put this on a graph. You see right here where they say plot the points on the graph below, then sketch the line. All right, so let me show you. So I hope you're able to go to number 7 right now on your homework, because I want you to see this with me while we do it. So what it is this is going to be like an XY graph kind of thing. So I'm going to go, let's do the first one, 13, 10. So I go over 13, up to 13's about right here, just past the 12, up 10, which is right here in the middle. So the dot is going to be right about there. Does that make sense how I found that? I know this is going to be difficult for some to find the exact spots because you kind of have to eyeball it a little bit. See how like between 12 and 16, we have like 13, 14, and 15, don't we? Like 14 would be right in the middle. 13's right there. 15's right there, right? And then 16. You see how that is? And then between 8 and 12, you have 10 in the middle, 9 just below it, 11 above that. So you see how you really have 3 marks in between each of these numbers? And so you kind of have to eyeball exactly where your dot goes using the graphing tool. So you'll see a little graphing tool, like a dot thing, and that's what you'll do to make it work. In fact, maybe it'd be best if I just showed you on my screen. Let me do that. Let me go back and share my laptop screen. All right, and I'm going to jump to number 7. You guys are all seeing my laptop screen now, right? You seeing this?
Yes. Yes.
So here, I'm going to do it with you. So I'm going to click on this dot right here. Yeah, this is what I should have done from the beginning. Yeah, let me click on this dot. So here's a table. This one's a little different. It's a little different version of the same question. Question 7. See this data. So I'm going to do the point 10, 10 first off. So I'm going to come down here. I'm going to click on the dot. I just clicked on that. I'm going to go 10. See the pencil that comes up? 10, 10, right there. Boom. See how that's right in the middle? Because 10 is right in the middle of 8 and 12. And 10, over 10, up 10. That's the point. 10, 10. X, Y, 10, 10. Quiz 1, quiz 2. Over 10 on quiz 1, up 10 on quiz number 2. See how the x-axis here is quiz 1, and the y-axis is quiz 2. So 10, 10. Let's do the next one. 11, 9. So I come down here again. I'm still on the dot. 11 is close to 12. 9 is close to 8. It's going to be about right there. See that? See how that's 11? It's almost to 12. It's not in the middle. It's not in the middle like the 10 was. It's closer to the right edge, but not all the way to 12. That's 11, and then up 9 because it's below, it's just above the 8. So there's 11, 9. See how I'm finding that? Questions so far?
I did mine, and it's like literally it's to the dot, pretty much on spot on every single one, but it keeps telling me that it doesn't give me the full point. It just gives me 90.
Yeah. It's very easy to have just one dot off when you think they're all right. I wouldn't sweat it a lot. Remember, homework points are small potatoes compared to test points. So I would not spend hours of my life trying to get 100% on this thing. It is right. I've tested it. Every time I think I'm right and it's wrong, it's not the case. It is right, but it's just easy to make a small mistake. Don't worry about it. If you get 90%, move on, would be my suggestion. Don't sweat it. Don't let it bug you. Let me keep going with this one. 12, 13. I probably won't get it full credit either. I'll mess up somewhere. 12, 13 is right there. See, I went over 12, up 13, just above the 12, and then 15, 12. So over 15, which is almost to the 16, up 12 right there. So that's over 15, up 12. Next point, 17, 14. Over 17 is past 16, up 14, which is halfway here. There's over 17, just past 16, up halfway, 14. 17, 20, 17. So over 20, up 17, which is right there, just above the 16, right? Over 20, up 17, just above the 16. And then 25, 24, over 20, it's just past the 24, over 25, up 24, right there. See how that's just past the 24, over 25, up 24. And then last one, over 29, up 28, over 29, it's just past the 28, up 28, right there. So that's over 29, up 28. Okay, now that's not all. Maybe that's the problem. So those are my good dots, but then it says, then sketch a line. You all see this part right here? Then sketch a line that best fits the data. So I have to put a line. I have to put a line that sort of goes through the middle of these dots. Now, honestly, this is pretty tough. And later, we're going to learn how to do it with our calculator. The calculator will do it. For now, just do the best you can. Don't worry about getting 100% on this problem. Again, homework points are not a big deal. Test points are. The purpose of homework is to learn how to answer it on the test. And on the test, I'm not going to give you things where you have to eyeball it. We'll be using our calculator. You'll see. So anyway, what I'm going to do now, how do you make a line? So they want me to make a line through the middle of this data.
How do you do your lines if you put too many?
It's this right here. See this right here? This is the line making tool. See how there's different tools here? So I've been using the dot maker to put those dots down, and that's been great and all, but I'm done with that now. Now I have to do the second part, then sketch a line that best fits the data. So I'm going to click on the line making tool, and I'm going to try to make two dots that'll make a line through the middle of this graph the best I can. So I'm going to go, I don't know, maybe about right there. And see how when I move this, I haven't clicked it yet. I just clicked the one dot. I can go wherever I want. I'm going to go, I don't know, maybe like sort of like that. Boom. That kind of goes through the middle. You know, I just did the best I can. I just clicked those two red dots on the line making tool to put a line sort of through the middle. And then down here it says, use the line above to predict the value of the second quiz score if a student had a score of 30 on the first test, or first quiz that they mean to say. So do you understand what this is? This is a relationship. This graph, these dots, are a relationship between how students did on the first quiz and how students did on the second quiz, right? Students that did better on the first quiz also tended to do better on the second. Not always, not exactly, but you can see how the dots kind of go up a line, don't they? In other words, there's a positive linear relationship between quiz 1 scores and quiz 2 scores, and that makes sense. Usually, students who did better on quiz 1 also did better on quiz 2. Like, look at the numbers here. This person did pretty badly on quiz 1, only 10 points. They also did pretty bad on quiz 2, 11, 9, 12, 13. Now they're getting higher, higher, higher. This person got 29 really well in quiz 1. They did really well in quiz 2. See how the people, they tend to go up together and down together, right? People that did better on quiz 1 also did better on quiz 2, and worse on quiz 1 also did worse on quiz 2. That means these two have a linear relationship to each other. So now let's get back to this question. What is this? Use the line to predict a student who got a 30 on the first quiz. Where's 30? Right, 30 would be right here, wouldn't it? On quiz 1, 28 and 32. It's right in the middle. Go on up to the line, right about there. So it looks like they'd probably get about 28 or so. I'm guessing it might not give me the full points, but do you see how I'm kind of eyeballing it? Do you see how I'm looking at the line there? I'm saying if you're about 30 right here, if you're 30 on quiz 1, so it's saying score of 30 on the first quiz, first test, if you go up, where are you going to be on the line? Well, about right there, right there. This dot right here would be a 30 on quiz 1 if you're on the line. So then there's, and why am I doing the line? Well, it says use the line. See, it says use the line to predict. So in other words, you're on the line. If you're a quiz score on quiz 1 of 30 and you're on the line, you're about right there, which means your height, your quiz 2, is about 28. So I'm going to type in here 28, and I'm going to submit it, see what I get. Hey, it gave me full credit. So, so you can get full credit, but it's easy to make a small mistake. Questions I can take, I can answer on that one.
Yes, the small mistake will be with that line that you put in the center, right?
I'm sorry, just a small mistake, what?
The small mistake, because I got a small mistake, will be that line that you're putting into the center of your points.
Yeah, you might make a small mistake on the line. You might put one of the dots in the wrong spot. Either one.
My thoughts are good. I think it's.
Yeah, it's easy to make some. And Crystal and I can check in the breakout time to try to help with that. With you, you can share your screen with us, and we can try to identify what might be the problem there. But does everybody see how I came up with that?
So, Mr. Heron, so the number 30 is like the first number that you're checking in, or how'd you do that again?
Yeah, you see right here, they said 30 on the first test or first quiz.
Oh, okay.
So I went 30 on quiz 1, went up to the line, and there would be on the line a score of 30 on quiz 1, and then I went over to find the connection to quiz 2. So a person who got 30 on quiz 1 would probably get a 28 on quiz 2.
Are you looking at the dot or the line of the graph?
The line, because it says use the line.
Okay.
Yeah, good question. So pay really close attention to all these words. They all matter. Use the line, and the 30 is first test, first quiz. Everybody seeing all those details? So I took the first quiz, went up to the line. It would hit about right there. I'm not looking at the dots. I'm looking at the line. On the line, a quiz 1 score of 30 is about right there for my line, and it goes over to a quiz score of 28. So that looks like it's this line right there looks like that point, not the dot, but I'm just saying the invisible spot on the line right here looks like it's over 30 up 28, doesn't it? Quiz 1 30, quiz 2 28. That's how I came up with that 28. You can try a new one, right? Just hit try similar, and you can, but of course it's a little bit tedious and long. And I made my line using the line making tool, 2 dots, those 2 red dots, and I just made it going through the middle of the data, which is what a best fit line is. That's what it means. Use the line above, or it says sketch the line that best fits the data. So the line that fits through the middle of the data. Other questions I can answer? Is that making sense on number 7? So this is a connection between 2 things. So we're going to do this all the time in this class. We're going to go to this idea of how 2 things connect. This is very important in real life. People do this all the time. They study the data to see how 2 things connect. So how does quiz 1 score connect with quiz 2? People that do better on quiz 1 tend to do better in quiz 2. We would say these have a positive linear relationship right here. Positive linear relationship. All right, so I'm going to move on if you're good. That was question 7. So I'm going to go back now to sharing my iPad screen. All right, and so we did number 7. I did a different version of 7. Now I'm going to go back to this is number 4. Wait, I think this is number 4, isn't it? No, that's 5. Here's 4. All right, so here's question number 4. Now, a scatter plot, what it is, it's a bunch of those dots that we just did. So this could be quiz 1 and quiz 2 again. I don't know what it is. But look at how those dots are laying out. Now, what we do is we try to form something called the correlation coefficient. So let me explain that to you. basically, if the dots of your, so when you do a bunch of dots like we just did for quiz 1 and quiz 2, if the dots line up in a perfectly straight line like that, we say your R, that's your correlation coefficient. Correlation coefficient is R. We say R is positive 1.0. If your dots, let me just give you a display here what's going on. If your dots go down in a perfect line going down, then we would say your R value is negative 1.0 because it's down. Whereas if your dots go up, but they do it kind of loosely, you know, not perfectly, a little more loosely, we would say maybe your R value is like 0.8. And if the dots go down kind of loosely, not a perfect line, we would say your R values may be negative 0.8 because they're going down. So negative, so R is positive when it's going up, for these two going up, and negative when it's going down. And the closer the dots fit to a line, the closer the R is to 1. So let me give you another example. What if coming down here, we had our dots like they're going up, but they're very, very scattered, you know, very loose like that. We would say, well, that R is maybe positive 0.2 or 0.1, or I don't know, just some really low number. You know, I don't know if it'd be 0.2, 0.1, 0.3, something like that, you know, something low. And same thing if the dots are really disconnected but going down. So we would say R is something like negative 0.3 or 0.1 or something, a low number going, maybe it'd be 0.1, you know, I don't know, going down like that. So that makes sense. So what R is a measure, the R is the, let me write it up here. R is the linear correlation coefficient. And so it's a measure of how much your data points line up. The more they line up, the highest you can be is +1 or -1 if it's going down. You know, that's the best. That's a perfect lineup for your data. And the worse your data is, then the lower the R value, the closer the R is to 0. If you have data, let me do one more example down here. If you have a bunch of data that's just wacko crazy, it's just like everywhere, doing nothing like that, you would say that R value is basically 0. There's like no linear connection with those dots. You know, if the dots are just like everywhere, they're not even forming a line at all, then you would say there's no linear connection. So this is a measure of how much the data, the dots, make a line. How much do they make a line? All right, so questions so far? Is this making sense?
Yes.
All right, let's look at the example that is before us. This example right here. Look at these dots they're giving us, right there. What do you guys think? In other words, what I would suggest is try to put a line through the middle. Doesn't it look like the line through the middle would look something like that, sort of? Doesn't it look like the dots are sort of going up to the right a little bit? So it's going to be positive. So R is going to be something positive, but they're not very tight, are they? So which of these values down here, which of those values, so it's not going to be the negative ones. It's not going to be 0, right?
It would be a 0.9.
Well, the 0.9, remember, they have to be tighter for that. 0.9 is really close to 1. it's going to be the 0.6.
Oh,
See when you're 1, you're a perfect line. If you're 0.8 or 0.9, you're a pretty tight line. The dots are pretty close. These dots are a little more scattered. So it's going to be not so close to 1. It's not going to be 0.9. 0.9 is almost perfect. 0.9 is almost 1, right? That's almost perfect. Those dots aren't perfectly lined up. They're pretty scattered. So 0.6. Is that making sense?
But why doesn't the line go the other way? Like, instead of going like how you drew it,
Right.
go like the opposite way.
Okay, yeah, let me try that. Good question. Yeah,
Why does it have to go like that?
Yeah, does it look, so I'm just simply eyeballing it, and I'm saying, doesn't it look like the data goes, well, you tell me, does it look like the dots go down this way? Is that the general pattern of the dots? Do they seem to be going down to the right? I would say no, just by my eyes. I'm just looking, going, nope. It looks to me like the dots are going up to the right. See how there's more dots up here, more dots down here? There's not any dots down here, is there, to the lower right? So I'm just simply looking at it with my eyes and saying it looks like the dots are moving up towards the right.
That makes sense.
But not super tight, huh? They're not perfect at all. That's why
No.
the answer is the 0.6, positive 0.6, not the 0.9. You know, 0.9 would be a really tight pattern. They would almost perfectly line up. So remember how the numbers work. If you're close to 1, they really line up. Or 0.8 or 0.9, they're pretty tight dots. And then if R is low, like 0.2 or 0.1, the dots are spread pretty wide. And positive for up to the right. And we always mean to the right. Whenever we say up or down, we mean to the right, up to the right, up, down to the right. We mean as you go to the right, are you going up or down? As you go to the right.
X always has a stronger relationship than the Y response, correct?
Well, we're trying to determine the relationship between X and Y. So they connect to each other. Just like quiz 1 and quiz 2, right? We were just looking at how the students in that class on problem 7 did on quiz 1 and quiz 2. There was a connection. Students who did better on quiz 1 tended to do better on quiz 2. And students who did worse on quiz 1 tended to do worse on quiz 2. So they were connected in a linear relationship. That's the kind of thing we're looking at. All right.
Okay.
So go ahead.
Well, my question is, the first variable X has a stronger relationship than response variable Y.
So you must be on a different question, right?
I'm on question.
Right, so I'll get to that. I'm on number 4 right now.
Okay, sorry.
That's okay. Yeah, so I'm just wrapping up 4. I hear your question. Let's get to that. So here's, so I'm going to go on to question number 5. Let me refresh the screen there. There we go. Question 5. Match each scatter plot below with one of the 4 graphs. Okay, so we're going to try to match these up. Let's give it a go. So, so I'm going to try to put some lines through the data. It looks like on mine, this one looks like it's going down to the right, down to the right. So this is going to be negative, right? Negative. My R value is going to be negative. This one's going up to the right. So my R is going to be positive. This one up to the right, R is going to be positive. So I got 2 positives, 2 negatives. And that fits. That is what the numbers are. I don't know if you can see my numbers. So can you see this? This is negative 0.83. This second one is negative 0.38. The third one is positive 0.37. The fourth one is positive 0.83. Okay, so with that in mind, let's start so let's take the two that are going up. So these two have to be these two positive answers, don't they? You tracking with me? Both those lines go up to the right, so they have to be the positive R's. So which dot pattern is tighter? This one, the top one, or the bottom one? Which of those two has a tighter dot pattern?
The bottom.
I don't see it that way. See all these loose, this is looser, right? This is tighter. You seeing all these dots down here that are kind of off to the side, further away?
I would say the second or third.
Yeah, these guys fit tighter together, whereas these guys are spread wider. See that? So this one's going to be the one closer to 1, 0.83, and this is going to be the 0.37 because it's looser, it's closer to 0. They're both positive. They're both lines going up to the right, but the tighter pattern has the number closer to 1, and the looser pattern has the number closer to 0. Okay, let's try the other two. So here we have this data, and then here we have this data. Which one of those is tighter? In fact, I didn't even do this correct. Let me just do that. There we go. See that one. This one's tighter, isn't it? See how that's tighter? This is looser. They're both going down. They're both negative R values. So this one, oh, this one should have been negative here. This is negative. Anyway, so this one should be the negative 0.83. And this one should be the negative 0.38 because he's looser. He's closer to 0. This one's tighter. He's closer to -1. They're both negative. They're both going down. So there we go. That's how I do those 4. Is that making sense there? Questions I can answer on that? How we doing?